Hi everyone, welcome to another tutorial. In this video I'll be demonstrating intercepting and manipulating unencrypted traffic on a local network. Basically doing a man-in-the-middle attack. If you don't know what that is, or you haven't heard the term man-in-the-middle, I'll briefly describe it. In this slide you can see an attacker inserting himself in between the communication of the target computer and the server. It could be facebook.com, twitter.com, whatever. And he's essentially eavesdropping on the communications. So if it's an unencrypted site, he could get the usernames and passwords of the accounts the target is trying to put into the server, or other sensitive information. So that's why they call it a man-in-the-middle attack. He's putting himself in between the communications. So that's basically the attack I'll be demonstrating today. So I've uploaded a website on a new domain which is unencrypted that I'll be using for this tutorial. So let's take a look at that. We'll just navigate to webofchaos.cx. And as you can see, I've got an input field here. If I click it, it says this connection is not secure. Logins entered here could be compromised. And on the top left, I've got a slash through the padlock, basically telling me that this is not a secure site, and any information I transmit can be intercepted by an attacker. So take a look at that. We'll open up a tool called Wireshark. Sniffing Wireshark. So this program here basically just analyzes traffic on a local computer. We just need to select our interface that we're connected to. Obviously I'm on WLAN 0. If you're connected through a direct connection, it'll be ETH0. So just double click on your interface. That's starting to capture the packets. I'll just enter a username and password. Click login. As you can see, it's returned login successful. Go to Wireshark, stop. And if you've never used Wireshark before, it will display the time that it captured the packets, the source, so the source IP address where the request was coming from, the destination to the server that the data is being received, the protocol. We've got TCP, HTTP, some R packets, and a few other ones as well. We're just interested in the HTTP packets at the moment, so to filter that, just go to the top fields drop here and go HTTP, and we've got 4 packets here. The first one is post request. It's sending information to a script called post.php, and it contains some application data, so we'll just right click, follow HTTP stream. As you can see, it's got a host name, webofchaos.cx. It contains a PHP session ID, and it's captured the username and password, which was sent in clear text. So that's vulnerability. The information isn't being secured when it's sent, so pretty much anybody on the network can read it. And you might be saying, that's all well and good, I can read my own data on my own computer, but how would an attacker intercept this data or exploit it? So we'll just take a look at that. We'll close Wireshark because we don't need it. I've uploaded a new repository on GitHub, so we'll just get that. Navigate to github.com/webofchaos. Click on repositories. Click on HTTP inception. Click on code. You can download the zip folder, or you can just git clone it, which is what I'll be doing. Open up a terminal and go git clone. Paste in the link. I'll paste this in the description as well, so you can get it from there if you want to. We've got two folders. One's Facebook, one's a keylogger, and the other's a zip folder. In Facebook, we've got the source code for the Facebook login page that you can download yourself. We've got the keylogger, which is a JavaScript keylogger, which I'll explain in a minute. And we've got a archive folder, so we'll just extract that. And yeah, this is the zero exploit, which is the man-in-the-middle attack framework, which we'll be using. So you can install that yourself if you want to. I've already got it running on my computer here. So if you're installing this for the first time, just do sudo -3 install.py, and that'll install the dependencies for you. And the main file is this one here. So start the program, just run that one. If everything's been installed properly, you will see an interface like this. It'll display your IP address and gateway, the interface you're using, and your MAC addresses. I'll disable it for obvious reasons. Now what we want to do, we want to scan the network. You can do that with a command called scan. This will just find the IP addresses on the network. Until it's retrieved some IP addresses. We got the gateway or the router. We've got the an IP address, which is my local machine, an iPhone, and the current device, which is this virtual machine's IP address. So the target's any IP address that's not this device. So enter 113. Enter it. We need to provide a module, so we can list them by going help. And as you can see, this has a port scanner, denial of service attack, ping request, inject HTML code, inject JavaScript code, replace files being downloaded, capturing information inside the network, redirect all traffic to a specified IP address, play background music, replace all web page images with your own, view all images requested by your target, shaking web browser content, and overwrite all web pages with your own HTML code. So the first one we can take a look at is inject HTML. So we'll just enter that command. Inject HTML. Enter run. We need to supply a custom JavaScript file. So I've got one here. This basically just enters, injects the word hacked into the header. So pretty simple stuff. And you can name it whatever you want. Just copy the path of that file, paste it into the terminal, /new.html. As you can see, that's injecting HTML code into the victim. Open up the browser, navigate to a HTTP web page. If you see this, because we're doing a man-in-the-middle attack, this is essentially come up. It doesn't come up on Chrome or Safari, so just be aware of that. And as you can see, we've got the hacked header on top of the web page. So this exploit is definitely working. Obviously the stack's pretty simple. You can do more malicious stuff like injecting a fake login page and sending those credentials to the attacker, and a few other things. This attack just is, I just basically just did it as a demo. So let's go back to the attacking machine, stop that attack. And the next attack we're going to do is inject.js. So just enter back, inject.js, enter run. Go to desktop, HTTP inception, keylogger. So essentially what this script's going to do, it's going to log all the keystrokes that the victim types into the browser, and it's going to send that to the keylogger PHP file, which is right here. And so we can get that information. So what we need to do is open up a PHP server. We can do PHP -S 0.0.0.0 colon 9000. You can use any point you want. I'm just using 9000. That's running. And we'll also need to download a tool called ngrok. So just navigate to ngrok.io. Which is a tool that basically allows us to send information over the internet without opening ports on our router. So just go download. It will detect your operating system here. If it's not there, just scroll down till you find it and click download. Save. Right, that's been done. Go to downloads, extract that new file. Fresh. And if you have a gear called that says ngrok, that's just the binary file. So to execute it, we just need to open up a terminal and go /ngrok http and 9000. So 9000 is the port and HTTP is the protocol. Could be, we can also do TCP as well, but for this we need to access a web server. As you can see, that's online, and we're going to have a local host on port 9000, and this is the routing URL that we're going to use. So just copy that. Go back to the JavaScript file, replace this IP information here, save it. Another thing about this PHP server as well, make sure it's a PHP server, not Python or Nginx, otherwise I won't be able to read the essentially it needs to be able to run PHP, so any other server that doesn't, you won't be able to function properly, so keep that in mind. So now what we're going to do is go to keylogger, copy that file path, same as the HTML, paste that in, keylogger.js. Now that's injecting some JavaScript. Refresh the page. Right, the page has been refreshed, so it should be injecting our JavaScript now. So we're just going to enter some information. Go over to the attacking machine. Looks like it's got some data, and it's created a new file called keylogger.data.txt. As you can see, it's captured the username and password information, which is good. The only other downside of this keylogger script is it doesn't provide us with a host name, so we don't know the website that they entered it in. And normally this sends the information in all capitals. I've converted it to lowercase. So essentially, if they use a password that contains uppercase and lowercase, you have to try every combination until we get the right account. So those are the downsides of it. So I'll just stop this attack. Close these servers down. And something else to mention about the ngrok session is that if you have a free account, the tunnel will only stay open for about 6 hours. If you plan on running an attack that goes over a couple of days, I recommend putting these keylogger files on a server somewhere, just so it's public and the script can always access it. So keep that in mind as well. I'm just going to go back. The next attack I'll demonstrate is the Deface Script. So this tool basically just allows us to deface any website they visit that isn't encrypted. So we'll just go run. Now it's asking us to specify a file containing HTML, and it's warning us to not put JavaScript in there, otherwise it will break the program. And for this script to work, we need to create a file called 0-html.html inside the home folder of the user, otherwise it will break the program. So we're just going to use this HTML file again. Just paste that in there, new.html. So overriding all the web pages. Just refresh the page. As you can see, that's worked. It's replaced the original page with our custom HTML that says hacked. So as you can see, this tool is pretty much just used for trolling people and that kind of stuff. So that's pretty much all there is to that type of attack. We'll just stop this one. go back. The next one we'll take a look at is sniffing the victim's traffic. So just enter sniff, enter run, and it has a module called SSL strip, which essentially strips the SSL and tries to downgrade it to HTTP so you can intercept it. We're going to load yes on this one, just because if you go no, the target browser more than likely won't be able to load any web pages. So I'm just going to select yes. The SSL strip is running. Goes to the target. Load up a web page. Right, now we're just going to enter some information. Click login. As you can see, I'm running Bitdefender web protection, which this blocks any unencrypted information sent to a server, which is a pretty good protection method. But for this tutorial, I'm just going to allow it. Normally, obviously I probably wouldn't do this, but it's my own server, so pretty sure I can trust it. Enter yes, resend. Now I'm just going to enter that information again. Click login. Login successful. Check the network logs. If you see messages like this, just ignore them. Control C to exit. And yes, we want to save the logs. And the logs are located at file system opt 0exploit 0sniff, and we'll view the text log. Scroll down till we find our server, which is the Web of Chaos Facebook login. Now it looks like we've got it here, webofchaos.cx. We've got the PHP session ID, and we've got the email and password of our unencrypted server. So we were able to intercept those credentials and get that account. So yeah, you can see why this is a massive problem. And we'll just take a look at the network logs as well. So as you can see, we've got some TCP data here. Some DNS queries. And HTTP packets. So again, we just want to filter HTTP as a protocol. And just scroll down until you see a post request. As you can see, we've got a post request and some application data, so that's probably it. Go follow HTTP stream. And as you can see, we've got that packet information here, PHP session ID and the username and password. So we've got that in the network logs as well, which is good. So that's basically how you intercept traffic on a local network. Just go back. And the last one I'll be demonstrating is the R download, which replaces all files being downloaded. So essentially we can swap the initial download with a custom file, which could be malware to get access to their computer and files, just something of that nature. So we'll enter our download, run, and we have to specify the extension that we want to swap. So essentially we will need to figure out what extension the victim is going to be downloading, and so we'll need to, normally you would run a network analyzer and intercept traffic to find that out, whether it's PNG, JPEG or EXE. In this case I'll just be using PNG. Just enter the extension. Now we'll need to supply the path and file of the download we want to replace. So I've got one called shell.py, which is a Python script, just has some shell code in it, which will basically give remote access to an attacker on this IP address and port. So pretty straightforward. And again, we're just going to copy this path, paste it in, /shell.py. All PNG files will be replaced with this shell.py. Open up a browser. I've created a downloads page on my server, so I'll just load that up. And it looks like our Firefox is not working in this case, so I'm going to use Chrome. Sometimes it does this depending on what images they have embedded in the page. And you can see a link that says download virus, and of course we want to do that. Looks like it's been done. Go to downloads, you can see it's generated a download called anonymous.png. We'll just need to change the extension on this one to .py. Looks like that's been changed for us. Now I've opened up a Python interpreter called idle, and I'm just going to open that file. And as you can see, it's got our Python shellcode here, which is basically just malware, and will create a remote session so we can get access to the file system. So as you can see, that's why connecting to a HTTP website is so dangerous. People can install malware on your system, get remote access. So be very wary of connecting to a HTTP server on a local public network like Wi-Fi networks, hotel networks, stuff like that. Generally it's a bad idea. And just stop that attack. And that pretty much sums up the attack section of the video. Now I'll demonstrate how you would detect these types of attacks and what you can do about it. I'm just going to run the inject HTML attack for an example. Just copy that path in. Right, that's starting an attack for us. Open up Wireshark on the victim's computer. Now just click on your interface. Mine's Wi-Fi. It'll start a packet capture. I'm just going to let this run for a minute. And I'm just going to stop the packet capture. Scroll up and you can see some ARP spoofing packets here. The source is coming from an Alpha Networks adapter and it's pretending to be the router, the gateway. If we scroll down we can see some more here. This Intel color is the actual gateway. And some more down here, and as you can see we've got some duplicate ARP requests, so that looks pretty suspicious. So if you see a ton of ARP packets being sent over the network from a device you've never seen before, more than likely someone's doing the man-in-the-middle attack against you. So that's how you would detect it. Now we'll look at what you can do to defend yourself against these kinds of attacks. I'll just stop this attack. I'll just open up my VPN, which is basically just creates a secure encrypted tunnel to the server you're trying to access, and all information between you and the server is encrypted. So these injection attacks and eavesdropping attempts will be essentially useless once we connect to a tunnel. Click connect. As you can see, I'm connected to a server in Belgium. Open this terminal, run this attack again. So injecting some code. Open up a browser. As you can see, there's no hacked header on this one. Nothing out of the ordinary, and that's because the packets are encrypted, so there's no way to inject anything into them now, essentially making that attack useless. So you can see it definitely works. Go back to the attacker's computer, stop that attack, go back, and I'm just going to intercept some traffic using sniff. Run, start SSL strip. That's been started. Refresh the web page. Now I'm just going to enter some information. Log successful. So let's just check the network logs now. File system opt, 0 exploit, and 0 sniff. Nothing really on that one. Check the network logs. Looks like we got a bunch of TCP requests. Let's just right click, follow TCP stream. You can see a bunch of encrypted data, so we can't really read any of this stuff. The only thing we can get is using Hydra authentication and a RSA certificate, so that's pretty much it. So all this information here is essentially useless to an attacker. So yeah, that's essentially prevented an attacker from intercepting any HTTP information, mitigating that attack. So that's pretty much it for preventing these kinds of attacks. Pretty simple. If you're on a public network or public wireless network, just use a VPN which secures your communications to a server. So pretty simple stuff. So yeah, that pretty much wraps up this section of the video. If you want to know more about man-in-the-middle attacks, or if you want me to demonstrate doing this with another attack framework like BetterCap, just let me know. And thanks for watching. Hope you've enjoyed it.